Hi, everyone. My name is Marcy Samuelson, and I am Marketing Manager for the Developer Initiative here at Oracle. And I will be your moderator during today's workshop. I'd like to welcome everyone to the Develop Apps Using JSON, XML, Spatial, and Graph workshop. I hope everyone is doing well and staying safe. I'm very excited to show you some innovative new technologies that you can take advantage of in the Oracle Cloud with Converged Database. During this workshop, we have many of our solution engineers to help you as you go through the hands-on material. We have Arvind, Manny, Priya, and other experts on the call that will be able to answer any questions that you have. Here is our safe harbor statement. I will give you a moment to read this. If you have any questions during the workshop, please put your questions in the Q&A area, not the chat, and someone will answer your questions as soon as possible. In addition, this workshop is being recorded and will be made available in a few days, and you will receive an email with the link. At this point, I will turn it over to Arvind, who will provide an overview of the Converged Database technology, and then we will get into the hands-on portion of today's workshop.
Thank you, Marcy. So here's a quick agenda where we'll talk about data-driven applications, a converged database, its architecture, and eShop.biz application, which is built and powered by Converged Database. Then we would follow up with workshop, and we'll also have an interactive Q&A over the chat. Okay, so what is data-driven applications? Let us step back and understand this. There's a lot of buzz around data-driven applications in the industry. In order for businesses across various industries to stay ahead and competitive, they need to understand their customers really, really well and understand their demands beforehand, like before they arrive. So to achieve this, the easiest possible way is to build a data-driven applications. Now, data-driven applications operate with a wide variety range of data sets like JSON documents, spatial, graph data, relational data, and then these are all scattered data sets. So very often the value is generated only when data sets are together and individually, rather than individually understood in real time. So these data-driven applications are built using data-driven paradigms, which are very new than the traditional way of building applications like microservices, events, or API-driven, low code, and then developed using CI and CD. Now, to build these data-driven apps, there are two approaches, which is single-purpose databases or Oracle Converged Database. And both of them are quite contrasting in nature. Now let us try and understand, how they differ and what they offer to us. To achieve a data-driven app strategy, what we discussed in earlier slide, we will have to build multiple single-purpose databases which are best of breed for data types or workloads which are used. Here, each of single-purpose DB, which is a document JSON store or a spatial coordinate store or a machine learning workload or a graph data store. So all of these are built for a specific purpose. And now that they are built for a specific purpose, right? Spinning off a JSON document store with a native API could be very easy in the beginning and could be really euphoric as well. But then as the enterprise grows, as the business scales, the requirements will be very demanding and could keep adding as well the requirements, or they could change, they could change halfway during the implementation itself. So the current requirement, once you build the JSON document store, let's understand that it has to do real-time analytics using cache. So now the application developers now need to write additional code on top of a JSON document store, or we'll have to build an additional or we'll have to build an additional spin off an additional database, which is a cache database, and then transfer the data from JSON document to the cache database, which is an additional step in this. Now, the developer also needs to understand that cache database and as well as analytics, and not just this. They have to understand the proprietary APIs very well to communicate among these three layers. This is not enough, right? The response time should be real fast for any business in this competitive environment. Now, this is just one requirement what we have spoken about. While the developers are trying to achieve this requirement, that the requirements keep adding as the requirements keep adding. Let's say, we are talking about additional requirement like a geospatial requirement, with graph influences being there. Now, since this is a single purpose database, we just have a document store. We don't have a spatial or we don't have a graph at this point in time. So now, not only we have to spin up a spatial data store and a graph data store, but also we have to write code, which also the developers have to write an additional code, which could communicate through their proprietary APIs among them. But then they also should make sure that the code what is being built over here is not actually hampering the initial requirement what they have built on the cache database with the JSON document store. Now, what this means is adding every change has a base cost, be it the spinning of the JSON document store or a spatial document store on the second layer. Now, this has an additional cost, which is a function of compute, network, storage, and then the developers have to code, the developers have to integrate, and then someone has to really manage all of this together. So this is one layer of the challenge what we are seeing. Now, additionally, all of these have to they also have to address security profiles of the new changes made to each of these layers of application, right? And they should be really in sync with the prime application logic, the way the application is built in the initial stage. Now, this also means that IT is now spending time writing complex application code for every change, which is made here. And all of this needs to make sure this change is kept in sync with every change kept adding, and the business as it grows and scales up further. So this is how a single purpose databases or a best of breed databases runs together. Now let's understand an altogether a different strategy, which is very contrasting to this, which is Oracle Converged Database. So as you can see in this Oracle Converged Database figure, it is hosting various different types of data models, right? Like JSON, spatial, graph, and also workloads like ML and in-memory, and there's also access with odds. So ConvergeDB hosts multiple data types, and now this is a great benefit to the development team. And now the dev team can use the REST data services, which is an odds technology, to generate value insights across the different data types what we see over here. They do not have to move the data from one database to another database. Rather than that, they could just move the machine learning algorithms, maybe to understand how a market basket analysis works on a particular data set, or they could run a booster algorithm on a different data set. Now they could also run a promotion campaign based on influences on a graph data type, or they could also use spatial coordinates with JSON documents together and generate greater insights. Now, all of this is running in one converged DB. What this means is there is no data and development fragmentation because it's sitting in one Converged DB, and this helps the time to market is blazing fast here. This is only possible since all of the data types are hosted in one converged database. Let's try to define what a converged database is. So it is a multi-model, multi-workload, and it is multi-tenant. So multi-model natively supports various models in one database, which includes a JSON, graph, spatial, relational, etc. And all of these multi-models have access methods, including SQL and REST APIs. And the graph could use a PGQL method to consume and analyze over here. When it comes to multi-workload, what this means is, the converged database is optimized for various workloads, be it a transaction workload, be it an analytic workload, or in-memory workload. These are very different workloads, but all of them can actually reside and host on one database. Now, let's also talk about multi-tenant. Multi-tenant means container architecture on the database type, which not only provides consolidation, but it also provides isolation and agility, all of them on the database type. So Converged database gives both the developers and CTOs what they really want, right? Which is developer productivity, and for the CTOs it is data productivity. Let's try and understand how Converged database accelerates innovation, simplifies IT, and as well reduces the huge business risk. Now, you can run this on an on-premise platform or an Oracle Cloud, or you could also do altogether hybrid implementation. Best of all, you can run a Converged database as an Oracle Autonomous Database, which is a fully managed cloud service. With real application clusters and sharding, we provide highest amount of scalability, and then in-memory provides the best predictable performance for the applications deployed on Converged DB. So features like data guard give you all-time high availability over here. Now that the data which is coming from various data types is unified, we give you the best of security in real time, and as well proactively and reactively, right? So technologies like VPD, data masking, encryption, data vault, audit vault, firewall protects the data in the Converged database. Right? REST data services, which works with all of these data types, like relational, spatial, JSON, which is a no-cost technology and is offered free with Oracle database, works both on-premise and as well as on cloud. Now, let me draw an analogy over here. So the standalone and purpose-built utilities like a desk phone or a pager, a calendar or a camera, right? So all of them, really existed for a really long time, but then they're all converged into one mobile phone. So mobile does all of these features for us. Similarly, a Converged DB supports mixing of workloads and data types and algorithms. It is a very simple platform, comes at lower cost and far more reliable than single purpose databases. It gives you a very high agility, and then also offers a unified security with management across all the data which is residing on one Converged database. So all of this together, enables very powerful synergies across the features. So if I have to map it up to a technical layer, right? So Converged DB does many wide variety of things. You do not have to move the data for machine learning. You just move algorithms. The programming languages, the web frameworks are pretty native and consume Oracle Converged Database to empower the development frameworks. The in-memory database gives the best of features where there are no code changes, and the objects are just based on the in-memory area in the database level. So you can arrive and generate a lot of value using a wide variety of multi-model data types together, and generate business insights from them. And then you have a deployment choice like on-prem or cloud or a hybrid as well. Yeah, so let's understand the eShop.biz application, which is powered with Converged Database. Now let's look at the Converged Database architecture. So this is the retail architecture what we have built, eShop.biz. Now here, this Converged Database is residing with JSON, XML, Spatial, and graph data type in one Converged DB. Internally, we have used 3 pluggable databases, which is a multi-tenant. And now JSON and XML are isolated from graph and spatial, and as well as from the application data. Now, you could actually go ahead and have silos of databases as such over here, but this is just one of the representation of the design use case what we have built. This sits on a compute layer, the eShop.biz application, and this is a converged database which is running on a different DBaaS platform. This application is packaged and is now running on a container registry. So the developer team can come back and apply the latest changes over here. Now, this is a application overview from the front end. So let's say Tom, who's a retail user, right? So he logs in. So this is the landing page of Converged Database. And then since he's a fan of Puma shoes, so he goes back and tries to search in Puma shoes. So this is the product inventory from which the Puma shoes are coming in. Here, let's say he selects these 2 shoes here, and now he basically gets them added to the cart, and then he executes his details over here, and then the order is successfully placed. So now this is the very business overview how the application runs. So let's understand how this works technically as well. So now this product inventory catalog page is typically a JSON page. Now all of these are stored in the JSON document format, and all the billing and as well as the payment gateway is running on XML over here. Let's try and understand how and where we're using Spatial. The eShop.biz store, since it has got both offline and online presence, when it comes to multi-workload, what this means is, the Converged Database is optimized for various workloads, be it a transaction workload, be it an analytic workload, or an in-memory workload. Really, go and shop there, if they want to do a offline shopping or a physical shopping as such. This shows the power where one database is holding different workloads and multi-model data types over here.
So I just wanted to thank Arvind for this overview, but at this point, we're going to give you some time to start using the technology that Arvind just talked about. And here's our agenda. In the next hour and a half, we'll provide you with a jumpstart to the labs listed in the red on this slide. We will have you sign up for a free trial. If you don't already have an account, set up your environment and perform the JSON and Spatial labs. There are other labs that you can perform if you have time or on your own after this workshop. Again, if you already have a trial or a cloud account, you may use that for this workshop. If not, we'll have you sign up for one. So there are 2 links provided for today's workshop. The first link is the lab guide, which provides the step-by-step instructions you will follow to perform the lab. You will have the lab guide available and then open up another browser tab to perform the steps in the lab guide using the cloud trial account. If you need to sign up for a free trial, you can use the second link provided on this slide. If you already have an account, please use your account to perform the lab. Once you have an account, you will perform the following labs. In Lab 1, you will generate an SSH key. The SSH Secure Shell Protocol is a method for secure remote login from one computer to another. SSH enables secure system administration and file transfers over insecure networks using encryption to secure the connections between endpoints. SSH keys are an important part of securely accessing the Oracle Cloud Infrastructure compute instances in the cloud. In Lab 2, you will download the Oracle Resource Manager stack zip file. And in Lab 3, you will set up a Resource Manager stack that will generate the Oracle Cloud objects needed to run your workshop. And finally, in Lab 4, you will start your database instance and listener from a PuTTY window. You will also set up SQL Developer. If you have any questions, please post those in the Q&A section in Zoom, not in chat, and one of the solution engineers will answer. Please remember to put all the information in one question and include the region name, database version, the page and step of the lab guide, and any error message text so that we can support you properly. Also, I just wanted to remind everyone to please read carefully and follow every step in the lab, and please do not skim. Each step is required for your labs to work properly. If your lab is not working, please check to ensure you followed every step first before posting a question. Labs 1 through 4 should take you about 40 minutes to complete. So at this point, we will give you time to work on them. And I will post those links in the chat. And before we start working on Lab 6, which is the next lab we'll be working on, we wanted to give you an overview of JSON Documents store in the Oracle database and tell you a little bit about what you will do in this lab. So at this point, I'm going to turn it over to Priya to give you an overview.
Hi everyone. In this video, you will be introduced to schemaless development strategy using a NoSQL style document store. And this has become very popular with today's application developers. So JSON as a document store in Oracle database is the obvious choice for developers looking for a NoSQL style document store. This is the information I'm going to be covering, like overview about JSON document store, how JSON is right fit for application development. You will see how to store and manage JSON documents, and also you will see highlights of JSON lab with respect to a Converged Database workshop. So modern application developers are choosing to store application data as documents instead of using entity relationship models backed by relational storage. The primary driver for this switch is the flexibility offered by JSON-based storage. This flexibility has enabled the application developer to be much more responsive to the needs of the business, as changes to the application data model no longer require changes to the database schema. This allows applications to be deployed and updated on a much faster cycle. The switch to document-based persistence has led to the adoption of NoSQL document stores for data persistence. Oracle Converged Database has been engineered to provide full support for this style of application development. The other major benefit of choosing to use Oracle Converged Database as a NoSQL style JSON document store is that you still have all the power of SQL when you need it. Use these JSON documents for application development and use the same for your querying, reporting, or analytics purpose. Coming to our JSON lab, so in step 3, you will see how to load JSON documents into the database. Also, there is no dedicated JSON data type. JSON documents are stored in the database using standard Oracle data types such as varchar2, clob, and blob. So in order to ensure that the content of the column is valid JSON data, a new constraint isJSON is provided that can be applied to a column. So this constraint returns true if the content of column is well-formed valid JSON and false if it is not JSON. Later in the lab 4 and lab 5, you will see how to insert a JSON document and how to update a JSON document, that to a specific portion of a JSON document. Lastly, you will see how efficiently you can perform analytics and reporting on JSON content. You will be leveraging set of new SQL operators and a JSON path language that brings the full power of declarative SQL to JSON data. These new operators present JSON keys to the SQL engine as relational columns. In this way, data from JSON documents can be filtered and joined using conventional SQL predicates just like relational data. So you will come across use cases where operators like JSON underscore value, JSON underscore query, and JSON underscore exist are used. So each of these operators has its own capability. Like if I talk about JSON underscore value, so what it will do, it will select a scalar value from some JSON data as a SQL value. Coming to JSON underscore query, so it will select one or more values from some JSON data but as a SQL string, basically retrieving fragments of a JSON document. JSON underscore exist, so it will test for the existence of a particular value within some JSON data. So this is all about JSON operators. Thanks for watching this video. See you at the live labs.
Thanks, Priya. So at this point, we will give you about 20 minutes to perform Lab 6 in your lab guide. Again, a number of solution engineers are standing by to help answer any questions that you have, so please don't be shy and put your question in the Q&A area. We are here to help. Welcome back. So if you didn't have time to finish the lab for the JSON lab, Lab 6, no worries. We will give you some more time in a few minutes to continue working. The next lab is on Spatial. In this lab, you will connect to your PDB and SQL developer and go through a number of spatial query examples. Before you start working on Lab 6, we want to give you an overview of Oracle as a spatial database and tell you a little bit more about what you will do in this lab. At this point, I'll turn it back over to Priya.
Hi everyone. In this video, you will be introduced to spatial features in Oracle database offering advanced capabilities that address all forms of applications, spatial workloads, and data sets. This is the information I'm going to be covering, like overview of spatial in Oracle Converged Database, understanding spatial analysis, its capabilities and features. Also, you will see Spatial Lab with respect to a Converged Database workshop. So spatial data is an integral part of almost every database. Any business data that includes location is spatial data. Sensors, satellites are generating massive spatial data sets which needs to be analyzed, managed, and processed. So Oracle's Converged Database provides the industry's leading spatial data management platform with native spatial data support, rich location query and analysis, native geocoding and routing, and map visualization. It's actually easy for developers to add spatial capabilities to applications with standard-based SQL and Java APIs, JSON and REST support, and also integration with database tools, Oracle Business Intelligence, and applications. Coming to spatial analysis, so it is all about understanding complex interactions based on geographic relationships, answering questions based on where people, assets, and resources are located. Spatial insights enable you to provide better customer service, optimize your workforce, locate retail and distribution centers, evaluate sales and marketing campaigns, and many more. If I talk about spatial features, so it supports all major spatial data types and models, addressing business critical requirements from many industries, including transportation, utilities, energy, public sector, defense, and commercial location intelligence. You can perform queries based on proximity, like how near or far something may be. And talking about spatial indexes, so it provides fast query performance on massive and complex data sets. Developers can easily add spatial capabilities to applications using modern application framework of their own choice without having to learn new languages. So Spatial do support database features like partitioning and sharding, which are used for high performance on large datasets. Coming to the lab part of Spatial, you will see spatial capabilities like its indexing mechanism, its functionalities, and how efficiently its operators, functions, and procedure works. Spatial has its own native data type, SDO_geometry, and an Oracle table can contain one or more SDO_geometry columns. So these columns with data type SDO_geometry are then registered with a row in table which will be its metadata. So all this information is available in the reference section of the lab. Also you will see some of the use cases in step 3 related to location analysis where spatial operators like SDO_NN, SDO_NN_distance can be leveraged for scenarios like determine the nearest neighbor geometries to a geometry or determine if two geometries are within a specified distance from one another. So all these use cases are covered as part of this spatial lab. Thanks for watching this video. See you at the live labs.
Thanks, Priya. So we will give you the rest of the workshop time to work on Lab 8 and finish up any other labs that you are still working on. Please let us know if you have any questions in the Q&A area. We are here to help, so please don't be shy. We'll have about 20 minutes for this lab, and then I'll come back and give you a couple of follow-up resources and places that you can go to get your questions answered after the workshop. So we have a Oracle community where we have a number of discussions that you can ask questions and people moderate this discussion group. And the link is provided down below. I also put it in the chat. So feel free to, after this workshop is over, if you want to continue with the lab, you can do so. And then if you have questions, post a question or create a new discussion here. That's the best way to get your questions answered. A couple of other resources that we have, I also put in the chat a link to a webcast that we have going on next week. Jeff Smith and Brian Spendolini are experts in some of our data-driven applications with database tools like SQL Developer and Apex. And they'll be talking about that during this session. So feel free to sign up for that. We also have some product information and documentation links provided on this page as additional resources. And then we have a number of other self-guided labs other than this one that you may want to take a look at and do at your own pace, and the link is provided. And then if you need some additional help for your particular organization, and want to talk to somebody technical, you can feel free to request a cloud coach, and the link is provided there, and they will get back to you and talk with you about the issue or question that you have. So those are the details. If you didn't finish all of the labs today, feel free to continue doing them on your own pace after this workshop is over, and then ask the questions in the community. Again, we will be posting the recording for this session in the next few days, as well as the slide deck to the recording, and so it will be made available, and you will receive an email with the link. So we appreciate you attending today, and we will stick around for the next 10 minutes or so, but otherwise you can go ahead and continue on. And we hope you have a great day.